My name is Martin Maas. I'm from Google. And I'm going to talk about how to get involved in RISC-V technical groups. So a few words about me. I'm a staff research scientist at Google DeepMind. I've been involved in the RISC-V project since the early days when I was a grad student at UC Berkeley. And at Google, I help coordinate our involvement in the various different RISC-V standard committees within RISC-V International. I'm also the chair of the J extension group, which is working on hardware support for managed runtime. So we work on things like a pointer masking standard, instruction data synchronization, and in collaboration with the runtime integrity group, starting to look at memory tagging. And I want to emphasize that in this talk, I'll be speaking in my capacity as RISC-V group chair, not for Google. Okay, so why get involved in RISC-V standards? There are lots of different reasons, and I think the high-level bit is really that RISC-V standards are evolving at a rapid pace, and this is an opportunity in being involved in shaping the ISA from a lot of different perspectives. So if you work in hardware, for example, being involved in RISC-V standards means that you can be a part of making sure that those standards match your microarchitecture and fit your different requirements. If you work on software, you can help ensure that RISC-V standards meet the requirements of your software and are maximally useful for the different use cases that the software ecosystem encounters. If you work on platforms, you can make sure that RISC-V fits into your existing ecosystems and matches best practices and fits into the various different application scenarios where RISC-V might apply. And if you're a researcher or a domain expert, this is an opportunity to actually apply research in a real-world setting and translate it into practical industry impact by getting research results into an ISA. So lots and lots of opportunities to be involved from lots of different perspectives. But the question that might arise is how do I get started? It all seems very intimidating. It's a very large organization with lots of different work streams going on. So how do I get started? And so this is what my talk is about today. And I want to talk about it from three perspectives. So I'm going to start by talking about the RISC-V organizational structure to give a bit of an overview of what the technical side of RISC-V International actually looks like and what the different groups are where one can get involved. I'll then go through the life cycle of a RISC-V standard and show you how do we go from an idea for a standard all the way to a ratified standard in the RISC-V ISA. And then finally, I'll talk about how to get involved in these different processes and where to best get started. Okay, so what does RISC-V International look like? And I want to emphasize that I'm focusing on the technical side here. There's a lot more on other parts of the organization, but this is basically the structure where the technical work happens. And so at a high level, there is the board of directors, that the technical steering committee that is kind of voting on kind of standards that gets them across the line to ratification, for example, and makes a lot of the higher level technical decisions. There's also a tech chairs meeting, which brings together the chairs from the various different groups and looks at things like ratification plans. And then there are a number of horizontal committees that oversee a particular area within RISC-V International. So for example, there is as Jeff already mentioned, there is an applications and tool HC, which is looking at that part of the software ecosystem. There's a security horizontal committee that is looking at security related topics, etc. And within each of these committees, there are groups that pursue different work streams within that area. And some of these groups are overseeing a broader type of work, and others are working specifically towards standards. If the standards are ISA standards, these groups are called task groups, and they not only report to one of these horizontal committees, they also report to one of two ISA committees. There's one for privileged ISA and one for unprivileged ISA. And basically, this ensures that you both have represented the higher, the kind of higher level goal of that standard, like for example with security, and also have a coordinated way of ratifying these different ISA extensions. For ISA extension, there's also an architecture review committee, which basically reviews the various different standards and ensures that they all fit into the broader picture of the ISA. There's two special groups, profiles and platform, which exist outside of the structure, and that we'll talk about in a bit as well. Okay, so those were a lot of different groups. So what does it actually mean? And basically, we saw the ISA committees. Those are basically overseeing extensions that go into the RISC-V instruction set. So anything that ratifies an instruction set extension in some way is going through one of these ISA committees. Then there are these horizontal committees, which are overseeing a particular topic area, and so groups oftentimes report either to a horizontal committee or to a horizontal committee and an ISA committee. There are different types of groups. There is the special interest groups, which oversee a particular area or work stream. So for example, one family of standards or one area within software or infrastructure. And there are long-standing groups that basically pursue this area and might over time pursue a number of different standards. And then there are task groups, which are more focused. And these are technical time-limited groups whose role is to finish one standard, get it into ratification, and then disband. And so structurally, the 6 report to horizontal committees. They oftentimes spin off these task groups to actually get ratify the standards, and then they can report into different overarching committees as well. So what do these standards groups do? Essentially, there are 2 different types of standards. There are ISA standards, which basically add extensions to the instruction set. So things like vector, floating point, etc. Those would be ISA standards because they modify the ISA. And then there are non-ISA standards, which still are standard like a security model, but do not actually modify the instruction set itself. They both get worked on by similar types of groups, but they have slightly different requirements for when they get ratified. There are groups that pursue other areas as well. So for example, there are groups that oversee a particular part of the software ecosystem, like some of the groups that Jeffro talked about, or there are also groups that produce gap analyses for different sectors that can then feed into informing how a particular area should proceed over time. And I want to give a couple of examples of the different kind of groups to give you a bit of a flavor of the kind of work that is happening. As I mentioned earlier, the platforms and profiles groups, they exist a little bit outside of the structure, and their role is to define high-level standards that provide compatibility within RISC-V. So profiles define standardized versions of the ISA for binary compatibility. So for example, they define a particular set of extensions and a particular set of settings that then can be targeted by binaries, Linux distributions, etc. And I think this was what was earlier referred to in as RVA 22, RVA 23, etc. So some of the earlier talks mentioned this already. And then the second group of this kind is around platform standards, which define a standardized environment outside the immediate CPU and instruction set, but once again to have a common target for RISC-V to basically run within. Next, there are the 2 ISA committees that I mentioned. And to give you an idea of the kind of things that these committees might oversee, the privileged ISA committees, for example, looked at things like cache management instructions, runtime integrity, controls transfer records, which is basically a performance profiling ISA extension. And then the unprivileged committee, you have things like floating point, you have a vector sig, you have a dynamic language, which is a group that I oversee. And so these are things that directly modify the ISA. Then within the software horizontal committees, you have different groups that oversee particular types of applications. So for example, there is an AI/ML group, there is a group for managed runtimes. On the privileged side, there is a group for hypervisors and trusted execution environments and so on. So these groups oversee something more on the software side. And then there are a number of other committees. There is the Security HC, which oversees standards related to security. There is ISA infrastructure, which is things like simulators and testings. There is SOC infrastructure, which contains things like debug standards, QoS standards, etc. And a technology horizontal committee as well, which looks at different sectors and how RISC-V intersects with these different areas. And so, as you can tell, there is a very large number of different groups. But they all oversee very specific areas. And so looking at these different groups is a way to figure out what is the area that you're most interested in. Okay, so now that we've looked at the overall structure, I now want to go into detail of what the groups are actually doing and how a RISC-V standard goes from an idea to something that is actually ratified and becomes part of the RISC-V ISA. And in order for a idea to become a standard, there's actually a number of different things that need to be provided by the groups working on it. And this is a very, very simplified list. There's a more comprehensive version of this, but I think it gives the high-level idea. So the key portion of an ISA standard is a standard specification, which is a document that is describing the standard, and there is a particular way that it is written. It's following certain standards, best practices, and so on. Then there needs to be a proof of concept, which is an implementation that has all the necessary components to show that the standard is actually viable and works in a real environment. There needs to be a formal model. RISC-V uses a modeling language called SAIL, and basically, as part of ratifying a standard, that standard gets added to that model. Similarly, there is infrastructure for test suites that a newly ratified standard also needs to provide. Then there's a whole area of ecosystem support that's very dependent on the extension and what type of functionality it's adding, but it includes things like software support, simulator support, support in the software ecosystem that is being targeted by that standard. Now, the standard progresses and is building out more and more of these different deliverables. And once it has reached basically a stable point, it's been approved by the architecture review committee, etc., then it goes into public review, where for 30 days it will be posted and everyone can provide feedback. And then that feedback gets incorporated. And then finally, once all of this is finished, there needs to be sign-off by various different committees, TSC and board. So there is basically a whole lot of things that need to be provided, but there is also a process by which a standard goes through these different stages and starts from an idea and then creates more and more and more of those over time. Okay, so how does a new standard start? And a new standard typically starts by kicking off a new group that will be working on the standard. And so the way that a new group is created is by working with a sponsoring ISA committee or a horizontal committee to draft a charter that basically sketches out, this is what will go into the standard, this is the purpose of the standard, these are the use case, etc. And this is usually driven by an acting chair and vice chair who basically write this initial charter, they build interest, they bring others who are interested in this area into this group, and are basically sketching out, this is what the group will provide. Once this preliminary charter has been drafted and there's sponsorship from the owning IC or HC, then it can go into kickoff, where it provides a call for a chair or vice chair and vice chair of that group, and basically makes this group formal. Then once all of this is finalized, it gets signed off, and then the group is active and can start to perform its group-specific work. In the case of a TG, that usually means that it produces the deliverables for the standard that it is ratifying and then disbands, whereas SIGs exist in a longer term until they're explicitly disbanded. So they can exist for a very long time. Groups have different ways of doing this. Some groups have a lot of online meetings. Others are operating mostly via mailing lists. This is typically up to the chairs and the dynamics of the group to decide how they run it. For groups that exist for longer, there is an annual re-election of chairs and vice chairs as well. So within that group, the group then proceeds to actually work towards ratification of a standard. And to do that, they start with a ratification plan. So the group sketches out a plan with a specific timeline of how the different deliverables will be met and who will be working on it. And this is then presented and signed off in the chair's meeting. Once it is signed off, the actual work starts within the group, which means the group works on the specification, works on the different artifacts and deliverables. At some point, it will go to architecture review, and the group will iterate with architecture review to make sure that it meets all the requirements. And then at some point, all the necessary pieces are in place, and the standard gets frozen and enters this public review period. At that point, there are no more additions to the extension, and the only changes at that point are usually to address reviewer comments. And then once this period has completed, all the changes are incorporated, then the standards get signed off and becomes a full ISA standard and part of the RISC-V ISA. There is a fast-track version of this where this doesn't happen in a new group, but it happens within an existing committee. But otherwise, this process is very similar. Okay, so this is the theory, but how does it actually work in practice? And I think it depends very much on the specific standards. So some standards are very simple and are ratified very quickly, are maybe developed by a small number of people, and other standards can involve multiple dozen people working on them for multiple years. It depends very, very much on how large and complex the standard is. But one thing that all of the standards have in common, that it's very important to have a combination of experts in the room, both from software and from hardware. Because software will be using the extension and hardware will need to implement the extension. So it's important to have both sides represented there. It's also important to have a range of different perspectives. So for example, you'll want different types of software that might use the same feature. And you want to make sure that different types of microarchitectures or hardware implementations are represented. And finally, it's important to have subject experts who can speak to the particular area that the group is working on. So for example, experts on different machine learning techniques, if it's an ML-related standard. And it's also important to have representative of particularly important stakeholder projects for that standard. So for example, if a standard needs to be supported by one particular software ecosystem, it's important to have that software ecosystem represented as well. So how to actually get involved in these different kind of areas? And I would say the best way to get started in RISC-V International is to join an existing group in your area of interest and participate. There is a great way to figure out what the various different groups and meetings are. RISC-V.org has a calendar and has a spreadsheet with all the different groups. And so it's very easy to go and see these are all the different groups that are currently active and join meetings of groups that are of interest. Once again, some groups are doing their work in meetings, some mostly do it on mailing lists, and the best way to find out is to join the mailing list directly online, and then meetings will be announced there, or maybe the group will mostly do their work on the mailing list. This is a great way to meet new RISC-V members and become part of the community. And in particular, all these groups have always some work to do, be it on contributing to the spec, or to the testing, or the formal model. And so one great way to get involved is to volunteer for some of this work and basically become part of the community and contribute to RISC-V. And then by doing that, building up expertise and knowledge of the RISC-V ecosystem and RISC-V standards. And eventually this can build to something bigger, for example, eventually running for a committee position oneself. And one thing that is very nice about RISC-V is it's really a very open and welcoming community. It's really possible to just join any meeting and become part of a group, and there is not a like a process of formally signing up. The only thing that is necessary is to be a member of RISC-V International. Only RISC-V International members can join the meetings, but there are various different membership tiers. All right. So in summary, RISC-V is really developing at a rapid pace right now, and participating in the standard body is an opportunity to be involved in shaping the standard and working on something that gets used in real systems and is having the various different impacts that we've heard about throughout the day. But the impact is, whether the areas in hardware, software, research, there's always something to do in these different groups across many, many different types of work. And the meeting are, as I said, they're open. It's very easy to join, very easy to become part of a group, and it's a lot of fun. So I would invite everyone to participate. And with that, I think we have a couple of minutes for questions. Thank you, everyone.